My name is Tim. Today I will be going over vector field for the project I've been researching for over the past few days. Okay, so first of all, I will be going over the definition of vector. So for the definition, so vector fields, it is a diagram that shows the magnitude and the direction of vector in different part of space. Okay, so that's what I mean. It's mean the magnitude and the direction in different space. So this vector, it involves force and velocity. Okay, and now I will be showing the unit of the vector, and the unit of the vector are the unit. Okay, that will be I, J, and K. And this line right here, they indicate vector. So the I, it represents the x direction, and J represents y direction, and K represents the z direction. Okay, so that's pretty much it for vector field. Okay, now we'll be moving on to a more sample. Okay, now we are going to look at fluid flow. We can imagine vector field as fluid flow to make it easier to see it, like the way it represents things around us. So for example, we have a graph right here, and these are the particle. So if the particle move like this, so this is the vector field right here. So they both move the same. So you see how these are similar? They totally the same. So in this case, we can say that the particle, they move along the vector field, and they move constantly. There are no changing in direction. So which means there's no change in the density of it, and therefore we can classify this as divergent. This is like an example of it. The vector field, it can be different, such as going outward like this. It can go like that, or it can go inward into the center like this. So this is going inward and this is going outward, but this one is constant because there's no inward or outward. Okay, so that's it. Okay, now we'll be moving on to real life example of it. So the first we got playing football. So let's say football or basketball, for example. We just make it basketball. So for example, a person is carrying a ball, and here's the hoop. So when a person shoots the ball, this is the velocity. So a player shoot the ball at the target. The target is the hoop right here. They unconsciously display a vector during this time, and this is velocity. The vector is to act upon the hoop. So when they shoot at the angle and with amount of force, which is related. So when it shoots the ball at an angle and with an amount of force, it is related to vector. As I mentioned before, vectors involve force and velocity. Okay, move on to the next example. We have a boat crossing the river. Okay, let's see for example. This is the current flow of a river. So if the river, let's say, assume that it moves this way, and the boat is right here, and we want the boat to go into this direction right here. So the angle in this case is really important because the velocity of the river is going this way, and so we have to move the other way to make it right here. So this create an angle right there. I'm gonna name it theta. So in this case, there are two velocity work together when a boat crossing the river. The velocity of boat and the river. So the boat direction, the direction of the boat that move in respect of the river, because this one is pushing the boat toward that way. So we have to control the boat like regular. Thus, in this case, you finding the angle, finding the angle for the boat to move its destination is really important, and vector take place into this. So let's say this angle right here, we have 4 and 11. Okay, so from math, we learned that the equation for finding the angle is our cosine is equal to a times the vector over the cross product of vector a and b. So with that, we have, so this one is from the vector and this one from the cross product, and with that we have 4, which is the vector, and this one is the 11 right here, which is the cross product, the product of the cross, which then it gives us an angle degree of 68 or 79 degree. So this angle right here is the angle needed. That's important to rotate up the boat finding the destination right here. That's how you use vector in real life to find the angle and to know which angle is right to move to the destination. Moving on. Okay. Now we're gonna move to an actual one, which is the gravity field, and which is the main example that we use in for my project. Gravity field. Okay, so for gravity field is just another example of vector that we interact on a daily basis. We deal with gravity all the time. So gravity is the force by which a planet or the other draw by object towards its center. The force of gravity keeps all the planet of orbit around the sun. And in terms of vector in the 3D graph, with x, y, and z axis, any given point of the graph will point toward the center, much like the graph. So for example, we have this right here. Sorry, I'm gonna make it so it's easier to see. Okay, so this is center, and all the gravity force go right into the center. So that's a basic meaning for gravity around us. Okay. So most of people already know, or they have learned about in physics. So the constant g, which is the gravity, is only 9.8 meter per second. Student can use this equation to find many different stuff through physics, such as finding the weight of something based on like how fast an object drops down from a distance. People can use that. I've tried it before. It's actually pretty fun. Okay, so that's gravity field. That's not all of it yet. Okay, so that's like an introduction to gravity field, and now we'll be on into our example. So we're gonna use the Earth as an example for this case. For the Earth, let's take an example of x squared plus y squared plus z squared equal to 1. So if I do that in a 3D plane, z, y, x. So with this equation right here, it's gonna give me a center, and we can assume that this is the Earth. That's the Earth right there. And now I will give the Cartesian formula, which is the vector formula, the vector field formula. It is x, y, z. Okay, so that's gonna be the field. I'm gonna be showing them in different color, not just one color. So it's gonna be all these vector forces, they are acting upon the Earth. It just keep acting on it. It's the vector force that keep the Earth down, or pull down the weight. As you can see, so this is like an illustration of my drawing. It's more accurate if I can show you the picture of it, but I can show it later when I include it into the video. Okay, so internal gravity, we can see that internal gravity, we can see that the vector keep us pulled down toward the center of the Earth. So it's gonna pull down into right here, into that point right there, into the center, and that's the equation for it. So in each point of the graph, they point to the negative counterpart. It's pointing to the negative counterpart, which then convert to the center of the Earth. So basically, in gravity, they just pull everything into the center. Okay, that would be it for